Welcome to the VulDB e-learning session, Introduction to the Moderation of New and Existing Vulnerabilities. Please take a seat and enjoy what you are about to learn. As usual, you will have the chance to try things yourself. If you want to engage as such, please keep your VulDB account data ready. And now, let's get started. In this session you will learn everything about moderation of vulnerabilities on the VulDB platform. This includes how to use the web interface, how to process the submission queue, how to approach an analysis, how to extract vulnerability data from sources, and how to process new data. It will be your task to add and maintain vulnerability data on the platform. VulDB stands for Vulnerability Database, and this is what the primary goal of our service is. We provide an open database analyzing and documenting vulnerabilities in computer systems, software, and electronic devices. We guarantee the most comprehensive catalog of vulnerability data. This means that we excel with a broad coverage of products and an extensive amount of vulnerability details. There is no similar service with the same coverage and quality available. We do also host cyber threat intelligence information. Please take a look at our CTI video to learn more about our unique approach of predictive analysis. Our service stands on three solid pillars. We provide extensive coverage of vulnerabilities, we process new data very fast, and we guarantee a high level of data quality. VulDB is known as the #1 vulnerability data provider worldwide. Our service is incomparable and excels the competition by far. This is only possible thanks to a professional processing of vulnerability data by our moderation team. This diagram illustrates the work done 24/7 by our different moderation teams and international vulnerability analysts. Don't worry, you don't have to memorize this chart. The analysts at VulDB are reviewing multiple sources on a regular basis. This includes automated and manual review of different data. As soon as new vulnerability data is identified, it will be added to the vulnerability queue. If you are part of the vulnerability moderation group, you will have access to the vulnerability submission queue. It is your task to moderate the queued items to add new and enrich existing entries. Now let's take a look how to use the web service of VulDB. On the top of a page, you will always find the main menu, which allows access to the different datasets and views. To do moderation of entries, you need to log into the service first. Depending on your permission level, you are allowed to process items in the vulnerability submission queue, edit or moderate existing entries. If you click on Entries and chose Queue, you will access the vulnerability submissions queues. If important items are queued, you will see them in the user menu as well. The vulnerability submission queue contains all new items that must be moderated. The queue is divided into different sub-queues. The main queue is the CVE queue. This queue contains all the items that were officially submitted to the CVE stream. This is the most important queue, as these vulnerability entries are readily available on other platforms as well. Therefore, it is of highest importance to process these items as quickly as possible to guarantee immediate availability for our customers. Other queues shall be ignored until this queue is fully processed. The CVE queue is also the easiest to maintain because no extended duplicate detection nor a manual CVE assignment is required. The NVD queue contains all CVE entries that were aggregated by the National Vulnerability Database by NIST. These should be the same entries like on the official CVE stream. If a CVE items gets moderated, the same items in the NVD queue should be approved automatically as well. There are other queues like Submissions and Miscellaneous. These contain all unstructured items gathered within the Internet. This might be social media, mailing lists, or vendor advisories. It is important for the quality of our service to be one step ahead of our competitors. Therefore, this list may contain items which are not yet incorporated into the CVE stream. They provide early disclosures of upcoming CVEs or contain vulnerability information which is not yet processed by another entity. In this case, an intensive duplicate detection and further CVE processing is necessary. We will discuss details later. On the right-hand side of every item in the queue overview, you will find three buttons. The red X will reject the entry. It will be closed, and if a manual submit by a VulDB user happened, the user will get a notification via email about the decline that we will not further process the entry. If you click on the submission ID on the left side instead, you will see the entry and have the possibility to declare a specific reason for a reject. The yellow clock symbol will postpone processing of an entry. It will be moved to the end of the subqueue. This is necessary if further coordination with external entities, the collection of additional data, or the wait for an embargo to expire is required. The green checkmark will accept the entry for further processing. Clicking this icon does not yet create a new entry but will open the edit view to review, complete and store the new entry. A high level of quality during vulnerability moderation is mandatory, and weak or even wrong moderation actions might hurt the service reputation. If you are uncertain, always ask your supervisor for guidance. If you accept a submission in the submission queue by clicking the green Accept button, it might take a few seconds until the form is loaded. A preparser is using the information stored in the queue to set up the entry for you. Under certain circumstances, even additional data from external sources mentioned, like CVE or the vendor advisory, is downloaded, dissected, and incorporated. Please be patient, as such a preparsing might take up to 10 seconds. As soon as the preparsing has finished, the edit form is shown. It is a reduced version of the edit form that you might know from editing existing entries. The reduced version contains the most important data fields only to make vulnerability queue moderation as easy and fast as possible. The preparsing does also try to identify potential duplicates. This is primarily based on unique identifiers like CVEs, advisory identifiers, and URLs. But the preparser is also trying to find very similar entries based on technical details and list them as potential duplicates. It is your task to assess these identified duplicates whether they are associated correctly. If a duplicate was detected, the entry and its details shall be merged into the existing entry. If no duplicate is shown or the duplicate detection is a false positive, a new entry shall be created instead. Whenever you are uncertain, ask your supervisor how to proceed. In this example, you can see that there are 3 existing entries with the same advisory URL. This might be normal behavior because some advisories contain multiple vulnerabilities, like in this instance. Therefore, you should check if this is the case or if these existing entries are duplicates of the very same new entry. One of the best indicators for a true duplicate is the associated CVE identifier. If an entry with the same CVE already exists, then chances are very high that this is a duplicate. Even though we apply a different entry splitting methodology than the CVE program, we tend just in very rare cases to add multiple vulnerability entries with the same CVE identifier. This happens if a generic CVE was assigned but multiple very distinguishable products by different vendors are affected. If you suspect the duplicate announcement to be true, you should click on the Submit button in the submenu for further analysis and processing. This will load the submission without loading the preparsed data into the edit form. The duplicate detection is started again, and you may select which of the existing entries is the duplicate of the new submission. In this case, the new submission data will be merged into the existing entry that have selected. If a user has submitted the entry, he will get a notification about the merge of the identified duplicate. Some submitters are not aware about duplicate handling or just skip this step. By letting them know about your decision, they agree in most cases and become aware that duplicate detection is an important aspect of their next submissions. If you still believe that the new submission is not a duplicate, you may select Create New to override the duplicate alerting and create a new entry from scratch as we have seen it just before. If you open a submit by clicking on the ID and the submit is not identified as a potential duplicate, the submission details will be shown. On top you will see all details about the submit, like the date and the submitting user. The submitting user is shown with his username, whereas a colored symbol informs about the trust in the user. In this case, the user and his submissions are not very trusted, as just 20% of them got accepted so far. A low acceptance rate will decrease the trust level. If the trust level is below a certain threshold, users are disallowed from submitting new vulnerabilities. The core information of the submission is the title, description, and source URL. These details help to determine the structure and legitimacy of a submit. They will be the starting point of the data collecting and enrichment during the moderation process. You can also see if the submitter requested a CVE to be assigned. This will introduce additional tasks to handle, which will be discussed later. Even though if a submitter does not request a CVE, it is our task as a CVE numbering authority to determine if the identified vulnerability is eligible for a CVE assignment. Below these submit details you will find the moderation details. These explain when the submission was approached last for moderation, which user was the primary moderator, whether the submit was accepted and which VulDB entry ID was assigned to it. In this case, all these details are empty besides the lock timestamp. You can see that we have just opened the submit for moderation. If you leave all fields empty and click on the reject button, the submission will be rejected. But you are also able to define a reason. This reason will be stored in the database for audit purposes. If a submission was made by a user, he will also be informed about the reject reason via email. Good reject reasons help all involved parties to understand why a submission could not be processed as desired. Submitting users might be able to learn what the requirements for a proper and valid vulnerability submission are. We do always recommend screening vulnerability databases manually to identify potential duplicates of submitted entries. Our own database is very helpful, of course. But do also check NIST NVD, as their search engine works slightly different and might be able to help your duplicate detection. We recommend searching by product name. Screen the results to determine if there are known vulnerabilities approaching the same vulnerability class and affecting the component, file, or argument name. Sometimes it is not easy to be certain if an already disclosed vulnerability is the same, especially if existing disclosures do not contain much technical details. If you are uncertain, approach your supervisor. Especially when we as a CVE numbering authority must assign a new CVE. We must prevent duplicate handling at all cost. If you know that a submission is a duplicate, but the duplicate detection was not able to identify the existing entry, you may enter the VulDB ID of the existing entry. This is the ID that is used in our URL to show a vulnerability entry on VulDB. If you accept this duplicate, it will be merged and the submitting user will be informed about this action. If you leave the duplicate field blank and click on the Accept button, a new entry will be created based on this submission. This is the same as like clicking on the green checkmark button in the submission queue overview. If you decided to create a new entry without flagging it as duplicate or rejecting it, the available fields shall be prepared properly thanks to the advanced preparser. Here we see a plain new entry without any indicators to be a duplicate. On the right menu you will find the summary and the main links of the submission. Use them as starting point for your analysis. It is mandatory to identify vendor and product name. It is also recommended to invest some time to define affected versions and vulnerability class. If such details are not known, the fields shall be left empty. We will discuss in detail how you may approach such a data enrichment. During this e-learning session we will test your knowledge once in a while. The first question is, what do you do if you expect a new submission to be a duplicate of an existing entry? The answer is, ideally you merge the new submission with the existing entry. Let's discuss some examples how to analyze, process and incorporate external sources. We will show some of them and explain how they may be used to complete an entry. As a vulnerability moderator, it is your task to fill the edit form of a vulnerability to add as much data as possible. To do this you will analyze a source, identify data points and add them to the vulnerability entry. There are important values like product names, affected versions, vulnerable components, and files. Don't worry, we will discuss them one by one. One of the main sources, especially for the CVE queue, is the CVE website itself. The website contains all CVE entries that are officially part of the CVE stream. It is possible to search for CVE identifiers. In this example we are looking at the entry CVE 2014-0160, which is the well-known Heartbleed vulnerability that was major news back in 2014. The CVE description contains a lot of useful information. We can see that the product, OpenSSL, is affected, and the affected version is declared as before 1.0.1g. This wording is important because in our field software version we need to store the last known affected version. OpenSSL is using characters for their patch releases and the release before the fixed version is 1.0.1f. Therefore, the version value shall be stored as less than or equal to 1.0.1f. Thanks to these version details we are also able to define the countermeasures. The first unaffected version number is 1.0.1g and the recommended countermeasure is to upgrade to this release. Adding version details will increase the usefulness of a vulnerability entry drastically. There are different possibilities to store version details. The simplest is a list of affected versions. These shall be delimited by a /sign. Such a listing makes sense if the number of affected versions is rather limited, like in the example shown. If whole version ranges are affected, it is either possible to use a wildcard with a trailing X or to use a less than equal sign. This will autocomplete all minor versions number during displaying an entry. There are other version definition formats which are not that popular, not supported, or just wrong. Use the preferred approach and the available alternatives only. Version handling is an important challenge. If a vulnerability description mentions that versions up to 10.3 are affected, how do you store this value? According to the description, it is unclear whether lower major versions below 10.0 are affected as well. Therefore, you shall define less than or equal to 10.3. The database will use autocomplete based on historical data to create the expected list of versions. If you are very certain that specific minor versions of 10.x are affected, you should list them delimited by slashes instead. But the description contains additional details. The vulnerable components are the implementations of TLS and DTLS. Therefore, these values shall be stored in the software component field. It is also explained which file is affected. Unfortunately, 2 files are mentioned, and we can only store one of them. We will always prefer the more important or popular one. As we don't know such details yet, we will just choose the first. Some vulnerabilities which are able to draw a lot of media attention are named. Such friendly names are widely used, not just by media. Popular examples were Poodle, Slow Loris, and Proxy Shell. In such cases, it is necessary to add the vulnerability name as well to improve identification and visibility capabilities of the entry. This specific vulnerability is called Heartbleed, as explained in the last sentence of the summary. When it comes to CVEs, another website is very important. We are talking about the National Vulnerability Database maintained by NIST. NVD incorporates all CVE data but might also add further details. Especially their CVSS scoring is relevant for us. A CVSS score ranges from 0.0 to 10.0 and indicates the risk of a vulnerability. CVSS vectors are very important as they help our users to assess an entry properly. Incorporating them also enriches descriptions of entries a lot as they consist of important data points. To create such score, a CVSS vector is used. This vector contains the attributes of the vulnerability. The attributes are separated by a slash. And the attributes consist of vector names and values which are separated by colons. In this example, we will discuss CVSS version 3. The upcoming CVSS version 4 will introduce some changes regarding attributes and values. But the basic principle will remain the same. The first attribute is AV, which stands for access vector. This attribute is used to determine where an attacker has to be to successfully exploit the vulnerability. Possible values are network, adjacent, local, and physical. Values are stored based on their first characters. N stands for network, A for adjacent, and so on. The second attribute is AC, which stands for attack complexity. It can have the values low or high and determines the complexity of prerequisites necessary for a successful attack. The third attribute is PR, which stands for privileges required, and indicates whether the attacker has to be authenticated to exploit the vulnerability. Possible values are none for unauthenticated attacks, low for simple authentication as a regular user, and high if multi-factor authentication or administrative accounts are necessary. The fourth attribute is UI, which stands for user interaction. It can have none if it is a purely technical attack that does not require any form of human interaction. Of required, which is typical for cross-site scripting attacks, for example. The fifth attribute is S, which stands for scope. It defines whether an attacker is influencing the targeted object only, or if other objects might be influenced as well. For example, a cross-site scripting vulnerability might affect a web application but does execute in the web browser. Therefore, it might be set to changed. If no such dependency is the case, the value should be left on unchanged. The three remaining attributes define the impact of the attack. Such is distinguished between confidentiality, integrity, and availability. The values can have none, low, and high. For example, if there is just an information disclosure vulnerability, confidentiality might be set to low and integrity and availability can be left to none. And a denial of service attack might set availability to low or high and leave confidentiality and integrity to none. It takes some experience to understand CVSS vectors and their attributes. Even though it is an industry standard, there is a lot of room for interpretation and philosophical discussions. It is not unusual that different sources create different vectors. In the end, it is important that they are similar enough to remain comparable. If you start entering new data, other fields might be autocomplete as well. For example, if you chose a well-known vulnerability class like cross-site scripting, the CVSS vector will get populated. The only field unknown at this moment is usually the requirement for authentication. You might enter the correct value if this detail is known to you. CVSS scoring is a core aspect of vulnerability analysis and rating. Do you know which values are used for a remote code execution regarding access vector and impact vectors? The access vector is set to network to address the remote aspect of the issue. And the impact values are either low or high depending on the possibilities of the attack. The impact values are confidentiality, integrity, and availability. The interpretation of unstructured sources introduces additional challenges. These might be vendor advisories, mailing list threads, blog entries, news articles, or social media posts. But the basic principle remains the same: the core values shall be spotted. These are details about the affected product, components, files, vulnerability classes, prerequisites, and impacts. The more sources you screen, the better you will become. Let's discuss some popular examples to give you a head start. This is an official advisory disclosed by Microsoft. In the title you will find the basic product and the component that is affected. The impact is declared as an information disclosure, which would be a CVE 200. Right below is the assigned CVE identifier and the release date of the advisory. Then follow the CVSS fields. These can be used as starting points for your own CVSS assessment. Our rating methodology is sometimes a bit different than the ones of other sources. Please consult our knowledge base for a detailed explanation. If you scroll further down, you will find the acknowledgements which mention people and companies that were aiding this vulnerability disclosure. More important is the list of affected products. Here you will find the product and version details which shall be incorporated in our vulnerability entry. These are the patch release notes as they get published by Apple. In the title you will find the product which got a new software release. In this case the fix is available for iOS and iPadOS as well. We add them both as a list delimited by slashes. The version mentioned is the one that fixed the issues which are listed below. This information shall be used as the recommended version to upgrade to. But we also know that versions before that are not affected, which is why we store this detail in the version field as less than or equal to 17.0. Apple groups security issues by affected components, which are used as subtitles. The description might contain additional data like remote exploitability or vulnerability classes. At the bottom of the grouping there is a list of assigned CVE identifiers. In this case 2 CVEs fall into the same class. You must create a separate entry for every single one of them. This looks like additional work but is quite comfortable because both entries will hold the same technical details. Vendor advisories are usually very similar. Here you see a disclosure in the customer portal of Red Hat. CVE identifier and disclosure date are shown on top. A description explains the cause of the vulnerability, and on the right-hand side you will find additional links. One of them is the weakness identifier, which in this case is CVE 200 as well. Further down you will find a list of affected products. Sometimes these consist of packages. In this case it is important to understand if this is a generic package available on other platforms as well, or if this issue affects a package which is bundled with a Red Hat product only. At the bottom you will find the CVSS vectors by Red Hat and NVD, which remain helpful to understand the structure of the vulnerability. Here you see an advisory that is provided by GitHub. On top you will find the title of the vulnerability, which usually contains the product name and the vulnerability class. Further down are description and sources. Sometimes there are vendor advisories mentioned or commit links listed. These might be very helpful to gather additional technical details like affected file names, functions, and arguments. On the right side you will often find the CVSS base vector, the CWE value, assigned CVE, and GitHub advisory identifier. For many open source products there are commits in Git repositories available. In this example we take a look at a security-related commit for the Linux kernel. Every commit contains a title which usually mentions the affected component and the vulnerability class. Further details are shared in the description. Sometimes they are rather summarized and do not contain much more details. And sometimes they contain every technical aspect that there is to know. You will also find the file of the commit. If multiple files were committed, you have to identify the one that fixes the vulnerability. If multiple files are fixing a vulnerability, the most important file shall be chosen. The code sample will contain the name of the function which is affected. In this case it is QFQ change_ag. You will also see the code that has been deleted, replaced, and added. With enough technical understanding you are able to verify the existence and consequences of bad coding practices. Git repositories, GitHub, GitLab, and Git look very similar. If you are familiar with one of these sources, you will not have a problem to approach the others as well. The more data points an entry has, the more data will be available to our customers. This will increase the quality of vulnerability entries very much. Which are the 6 most important data points that should be filled whenever possible? It is very important to document the vendor name, software name, affected version, vulnerability class, advisory URL, and assigned CVE identifier. Add as much data as you can. At the end you may submit your new entry. The commit summary will list all edits that you have submitted. It is also shown if and how they were accepted. The service will validate your commits, correct or reject them. For example, if you submit a date, it will be converted to the appropriate Unix timestamp representation. This behavior is intended. Please be aware that editing a vulnerability entry will create proper commits in the monoblock database. This data will be live and cannot be revoked. Changes to published entries will not update the fields but add the new data to the existing commit history. Therefore, users are able to see old commits as well. If they consist of weak or wrong data, this might decrease the trust in the database. If you realize that you have just made a mistake, you can re-edit the entry with the regular edit feature of the service. If you do this within the first few minutes, it is still possible to overwrite existing commits. This does not hold true at a later moment, as from then on commits are always added instead. If you determine a severe mistake, please contact your supervisor immediately to handle the case properly. All users are able to edit existing vulnerability entries. To edit an entry, you may open it and select the button Edit on top of the page. This will open the edit form that you know from moderating new submits. It looks very similar but contains a lot more fields. Their purpose and expected content is documented in the knowledge base. Regular users without vulnerability moderator permissions may submit their changes. These will be moderated, and only accepted commits will be live. This prevents abuse and guarantees a high level of quality. We do also provide a Vulnerability Edit API, which makes it possible to commit changes automatically. However, this API is available for internal employees only to process large portion of data very quickly. Therefore, regular vulnerability moderators have to use the web frontend to create and edit entries. Vulnerability moderation is not an easy task. Occasionally a mistake might happen. What shall you do if your moderation appears to be wrong? If you realize this quickly, You shall edit the affected entry to overwrite the false data without such being stored in the entry's history. If you realize the problem too late or it is more severe, you must contact your supervisor to solve the problem. Approaching wrong data should happen as soon as possible to prevent propagation of such to our customers. The high level of quality is an important aspect of our services. Under certain circumstances we come in contact with entirely new vulnerabilities. This means that these are not yet in our database, not documented anywhere else, and do not have a CVE assigned to them. This might be a random disclosure in the internet or a new vulnerability submit by one of our users. VulDB is an officially certified CVE numbering authority by MITRE. This means that we are allowed to handle, assign, and publish new CVEs. Every CNA has a scope which defined in which context they are allowed to manage CVEs. We are allowed to handle every vulnerability and product that is not covered by another CNA with elevated priority. Most CNAs are vendor CNAs. They are responsible to handle the CVEs for their own products. Popular CNAs are Microsoft, Apple, and Oracle, for example. Whenever we want to disclose a vulnerability for a product of another vendor CNA, we must contact them first and coordinate the assignment. In most cases, the vendor CNAs request the CVE handling to be transferred to them. Bound to the official CNA rules, we happily do that. Let's discuss the process of CVE handling if a vulnerability falls into our own scope. The moment we become aware of a vulnerability, we try to verify the existence and determine if this might be a duplicate of an existing vulnerability. If it looks like it is a new vulnerability, we try to contact the maintainer and inform them about the emerging threat. The CNA rules expect a certain degree of effort to initiate a coordinated disclosure. If the vendor does not deny the vulnerability, we might prepare a CVE reservation to establish a normalized communication possibility. If the vendor or another party discloses the vulnerability, we do also finalize the CVE assignment, prepare our entry and publish them. We do the very same if negotiated timelines are violated or the vendor provides countermeasures. If the vendor declines the vulnerability but we still think it does exist, we determine if there are any legal risks associated with pursuing the vulnerability disclosure any further. Legal threats nor risks shall prevent us from disclosing vulnerabilities to help potential victims to understand risks and mitigate them. To reserve, assign, and publish CVEs you need special permissions as a CNA moderator on the VulDB platform. Not every vulnerability moderator is allowed to handle this delicate task. CVEs are generating a lot of attention in the industry, which is why the highest level of quality and professionalism is expected from our CNA team. As a CNA, we are bound to the official CNA rules. These are quite complex and introduce some dependencies. Our CNA team needs special training to handle CVE assignments properly. The CNA team is able to reserve CVEs. To do this, the year of the CVE must be defined. This will also become the year portion of the CVE identifier. The CVE year is the year that a vulnerability got disclosed or reserved. It is not possible to reserve CVEs for years in the future. As soon as a CVE was requested for a specific year, it is in the pool of our reserved CVEs. We can then assign it to vulnerabilities and entries. This reservation state will be shown on the CVE website. But there will be no details available about the responsible CNA or the associated vulnerability. A vulnerability moderator might add the reserved CVE to an existing or a new entry. This happens as usual within the edit feature of an entry. As soon as this data is committed, the associated CVE data will be public on our service. The CNA team may sync this data to the CVE stream manually. But such an individual sync is not necessary as new CVE assignments will be pushed by the system on a regular basis. As soon as the CVE data is uploaded, the CVE entry will change the status from reserved to public. All CVE details will be available on the CVE website as well. And other services like NVD will fetch these details and incorporate them in their services too. Every CNA has a scope which defines their boundaries and allows them to act within these. Well, what is the scope of VulDB? Most CNAs are vendor CNAs which are responsible for their own products. VulDB is a researcher CNA and allowed to handle all vulnerabilities and CVEs that are not part of another CNA. Vendor CNAs always have priority over researcher CNAs. If we become aware of a vulnerability, we have to determine the vendor and identify their CNA status. If the issue is within their scope, we have to hand over CVE processing to them. In this course you have seen how to do vulnerability moderation. We have discussed how to use the web interface, how to process the submission queue, how to approach an analysis, how to extract vulnerability data from sources and how to process new data. It will be your task to add and maintain vulnerability data on the platform. Be aware that this is a very important task, and the quality of your processing defines the visibility of our services. This is it. Thank you very much for taking the time to take this course. We hope that you had the chance to learn something about vulnerability management and vulnerability moderation. As a vulnerability moderator, you are a very important part to lead VulDB to success. There are a lot of details and possibilities to discover. Our developer teams keep adding new features on a regular basis. We wish you all the best, stay safe and secure.